Let's explore Chapter 10, Review Exercise 4, entitled Big Chickens. Growth hormones are often used to increase the weight gain of chickens. In an experiment using 15 chickens, 3 chickens were randomly assigned to each of 5 doses of hormone, 0, 0.2, 0.4, 0.8, and 1.0 milligrams of growth hormone. The subsequent weight gain in ounces was recorded for each of the chickens, with the equation of the least squares regression line being y hat equals 4.5459 plus 4.8323x, where x was the dose, one of these 5 numbers, the dose of growth hormone, and y was weight gain. So we're predicting the weight gain from the amount of the dose that they got of the growth hormone. The standard error of that slope, 4.8323, is 1.0164. Assume the conditions for performing inference about the slope of the true least squares regression line are met. In part A of this problem, we're asked to state the hypotheses for a test about the relationship between dose of growth hormone and weight gain. So the null hypothesis is that beta equals 0. That is, the slope of the true least squares regression line relating the dose of growth hormone and weight gain is 0. There's no real association between the amount of growth hormone they get and the amount of ounces they gain in their weight. Now, to determine the alternative hypothesis, we're going to look back at the question, the very first sentence of the question, and notice that it says growth hormones are often used to increase the weight gain of chickens. This would imply that the alternative hypothesis is going to be beta is greater than 0, saying that the slope of the true least squares regression line relating dose of growth hormone and weight gain is positive, implying that the more growth hormone these chickens receive, the heavier they're going to get. Part B of this problem asks us to calculate the test statistic and p-value for a test of the hypothesis that we just stated. This is going to be a t-statistic that we're calculating. B is the slope we got from our sample of 15 chickens, the 4.8323 number. Beta from the null hypothesis is hypothesized to be 0, and the standard error of the slope is listed here. That gives us t equals 4.75. To find the degrees of freedom, we need to remember that there are 15 chickens and that the degrees of freedom is going to be n minus 2. So we're going to use the t-distribution with 13 degrees of freedom and find that 4.75 is still very far away from the mean. And using Table B, the probability that t exceeds 4.75 is very, very small. We could also use technology to determine the exact p-value, although this is sufficient for our purposes. Part C asks us to make a conclusion based on the p-value we got in Part B. And since our p-value is very small, less than 0.05, we're going to reject the null hypothesis and conclude that there is a positive association between the dose of growth hormone and weight gain. That is to say, the higher the dose of growth hormone, the more weight the chickens are going to gain on average.